Howdy, do you get confused by density and density altitude? Well, in this video, I'm going to go into full detail about how density and density altitude works. So make sure you watch the whole video. Now, I know this video is going to be a little bit long, but you need to watch the entire video because this whole video builds up to the end of the video. And so without watching the whole video, you're still going to be lost on how density altitude works. So I'm Dr. Andy Moltar. I'm a CFI, double I, MEI. I used to be a corporate pilot, and now I'm a professor of aviation. And aviation weather is one of the classes that I teach. So, you're getting free college education on aviation weather. All you have to do is subscribe so you get notified every time I come out with one of these videos. All right, so density. Density is the ratio of any quantity to the volume or area it occupies. So air density is the ratio of the mass of the air to the volume of the space it occupies. So when we're looking at these pictures here, I'll go ahead and turn my laser pointer, and I'll be doing that throughout this video. So here we just have a volume of space, and we have the air particles inside of it. Now, we have the same volume of space, but there's more air particles, so the pressure is higher, and so therefore, but it's the same amount of space, so we would say the density is higher. But if we increase the volume of that space, then we would say the density is lower. Even though it's the same amount of air particles, the density is less. So the density of an air particle can be changed by changing its mass, its pressure, or its temperature. And Boyle's law says that the density of air is an ideal gas where ρ is equal to the molar mass times the pressure divided by R, the universal gas constant, and T, the absolute temperature. All right, well, that's enough physics. So let's just actually try to think of it intuitively. So, like we said, density is directly related to the pressure. And so, if we're looking at this picture here, where we're at the surface, you see that the air that's, in previous videos, I talked about pressure. And so the air is a gas that's made up of molecules, and those molecules have mass. And so that air is sitting on top of each other. And so it just gets pressed down the closer we get to the surface. And so that's where we have the most air in that small amount of space. So we would say the density is higher. As we go up in altitude, the density becomes less and less. Well, the same thing happens with temperature. So here in the center, we have, we'll just call it a standard atmosphere. As the temperature increases to the right here, the air expands. So it's the same amount of air, but because the volume of space expands, then we would say the density is less. But as the temperature cools here to the left, it's the same amount of air, but it gets compressed, and so the density is higher. And so you need to remember, density so when we talk about density, it increases both, or the density changes with changes in altitude and changes in temperature. And so with that, just going back to it, when we go up in altitude, the density decreases. And then starting from the left here, as temperature increases, the density decreases. As the temperature decreases, the density increases. And it doesn't matter what the temperature is, as we go up in altitude, the density decreases. Now, you might be asked, okay, what affects density altitude? Well, it's going to be temperature, pressure, and relative humidity. So the water vapor in the air takes up space that air could take up. So if you have a higher relative humidity, well, the density altitude is going to be less. Now, as you'll see later on in the video, we'll calculate density altitude. We don't actually factor in what the relative humidity is. So it doesn't make that much of an effect, but it does make an effect on the density of the air. All right, so when we're flying, you've probably heard that saying, when flying from an area of high pressure to low pressure, look out below. From when flying from an area of low pressure to high pressure, you're too high. Well, you probably know that if you've been flying, but you want to know the reason why. So let's try to think about it. So as we're flying along, I'll go ahead and give you my laser pointer here. So as we're flying along here, we're in an area of higher pressure. And if we do not change our altimeter setting, then as we're flying along, what's going to happen? Well, when you're looking at your altimeter, it's going to start indicating a higher altitude because let's try to remember what happens when we go up in altitude. What happens to the pressure? It decreases. When we descend, what happens to the pressure? It increases. So if we're flying along and the pressure starts decreasing, the altimeter is going to think, "Oh, hey, we're climbing." And so what do you do when you're flying in the airplane? Well, you're right. You have your hands on the yoke and you push down because you think you're climbing. Well, so let's say we're going from an area low pressure to high pressure. You know, what does your altimeter think you're doing? Well, it probably thinks that you're descending because normally when you descend, the pressure increases. So if you go from an area low pressure to high pressure, the altimeter thinks that you're climbing and it indicates an increase in altitude. So you would actually start, pulling back on the yoke to get yourself to what you would think would be the correct altitude. All right. Well, the same goes for temperature. So pressure and temperature are directly proportional. So as we have an increase in pressure, we have an increase in temperature. As we have a decrease in temperature, we have a decrease in pressure. So, try to imagine you're flying along, you go up in altitude. What happens to the temperature? It decreases. You descend down in altitude. What happens to the temperature? It increases. So if so, just like flying from an area high pressure, low pressure, look out below. When you're flying from hot to cold, look out below. When you're flying from an area low pressure to high pressure, you're too high. Well, flying from cold to hot, you're too high. So just like you're flying along. I'll go ahead and give you my laser pointer here. So you're flying along, and the air temperature starts decreasing. Well, normally when we climb, the temperature decreases. So your altimeter, it's not measuring the temperature, but because of the pressure change, it thinks that you're it thinks that you're climbing. So you at the controls are going to force your airplane to go down in altitude so that you can indicate the same altitude that you want to be at. Well, the same is in reverse. If you're at a colder temperature, which means that you're also going to be at a higher pressure, when you start going into warmer air, the altimeter thinks it's lower pressure, and so it's going to start showing you lower altitudes, and therefore you're going to climb up in altitude. All right, so density altitude. If you've made it this far, keep watching. We're getting to the good stuff. All right, so density altitude. So density altitude is a pressure altitude corrected for non-standard temperature. Going through flight training, you're going to hear that definition so much, eventually you just have it memorized. And so it's pressure altitude corrected for non-standard temperature. So density altitude is indirectly related to the atmospheric density. So a high density altitude equals low density air, and low density altitude means high air density. Now, I know you put all those words together and then you start to get confused. Well, let's take the word high density altitude, take the word density out of it. So high density altitude, take out density, it becomes high altitude. What kind of density do we have? It's low density air at a high altitude. So high density altitude is a low air density. And so low density altitude, we take that word density out of it. So low density altitude, low altitude. What kind of density do you have? You have high air density. So that's an easy way to remember that. And so with a high density altitude or low density altitude, when you factor in elevation, then we can get our true density altitude. And temperature has the greatest effect on the density altitude. And so density altitude is an index to aircraft performance. So if we have higher density altitude, it's going to decrease our aircraft performance when we're trying to take off or land. And then a lower density altitude increases that aircraft performance. And a high density altitude is hazardous because the engine takes in less air. Remember, the engine, the way we make power is by burning air. We use the fuel for combustion of the air to make that air hotter. And so the more air that we are able to heat, the more power we're going to make. So at a high density altitude, it feels like the airplane's at a high altitude. And so there's less air, so we make less power. And for that same reason, the propeller is going to produce less thrust, and we're going to reduce the lift generated by the airfoils. So changing the density altitude does not affect indicated airspeeds. True airspeed and ground speed do increase proportionally, however, as density altitude becomes higher. And so higher density altitude affects performance by longer takeoffs and landings, lower rates of climb, and lower service ceilings. So if we look at this airfoil here, you'll see, this is just going back to Bernoulli's principle. You'll have air that flows over and under the airfoil. On top of the airfoil will be lower pressure because, the FAA used to say it for the longest time, and then the NASA proved them wrong. But the idea basically is that as air flows over and under, those particles that separate at the leading edge of the airfoil, they meet at the trailing edge at the same time. And so, because the air on top of the airfoil is going faster, it's going to have a higher velocity and therefore a lower pressure. And it's kind of like when you're a kid walking around in the mud and you get your foot stuck in the mud. What happens when you try to pull your foot out? Well, you're creating a void of space with no air. So what's the pressure? It's extremely low. So it sucks your foot back in. And so that low pressure is sucking up the airfoil, and we're creating a lot of lift by that. But in a high density altitude environment, so let's say you're trying to take off, because it's a high density altitude, it feels like for the airplane, a high altitude, there's less air traveling over the wing, and so therefore we're creating less lift. And your ground speed has to actually increase so that we get more air flowing over the airfoil. Therefore, we get that lower pressure that we need to generate the lift that supports the weight of the aircraft and lifts that airplane off the ground. Now, this third bullet point here says more fuel burn during cruise. The fuel burn will be greater, but at a high density altitude, there's less air, so you're going to have less drag, and you'll actually go faster. And when you go faster, your speed is greater. We're going to spend less time flying, and because it's less time flying, we're actually going to burn less fuel over that amount of time. So for that reason, we actually do want a higher density altitude during cruise. That way we go faster, we burn less fuel. All right, so here's just an example of taking off with different density altitudes. So at the top here, our takeoff roll is 1,300 feet, and then we start climbing out. We have a 1,300 foot per minute climb rate. And we fly by this mountain peak, and we fly over this mountain peak. But when, let's say, the density altitude is 5,000 feet on this bottom picture, now our takeoff roll is 1,800 feet because we have to have more distance to accelerate to a speed where we have enough air flowing over the airfoil. And then we finally take off, and we only have 1,000 foot per minute climb rate in this aircraft. And we're not making it over this mountain. We crash. So you definitely need to use your performance charts to understand how the density altitude will affect your climb performance on a day like today. All right. So high density altitude benefits include less drag during cruise flight, like I said before. And we can use a flight computer to figure out what density altitude is. And I'll make a separate video sometime in the future showing you how to use a flight computer. But we also have a formula to calculate density altitude. And so the formula is density altitude equals pressure altitude plus, and then, go back to PEMDAS and math, inside the parentheses first, outside air temperature minus international standard atmosphere temperature. Do you remember what ISA temp is? Well, that's 15 degrees Celsius. So you take whatever your outside air temperature is, subtract your ISA temperature of 15 degrees Celsius, multiply it times 120, add it to your pressure altitude, and that'll equal your density altitude. So an example of this is it's 15 degrees Celsius for ISA temperature, but it's 40 degrees Celsius outside, which is like 100 degrees Fahrenheit. So 40 minus 15, that's going to equal 25. Multiply that times 120, and then we add that to 2,000 feet, and that's going to equal a density altitude of 5,000 feet. So let's say you're at an airport with an elevation of 2,000 feet with the adjusted for pressure, so that's our pressure altitude, but it's 100 degrees outside, well, we're going to have a density altitude of 5,000 feet. So even though the pressure altitude is 2,000 feet, it feels like for the airplane we're taking off from an airport at 5,000 feet. So yeah, we're going to have a much longer takeoff roll. Our climb rate's going to suffer. So therefore, but when we get up to altitude, we're going to cruise really well because we'll have less drag and we'll burn less fuel. All right, so that's the last of this series for pressure and density. And so, go back and watch those videos if you haven't. Do you remember how an aneroid barometer works? Can you list the different standard units of measurement of pressure at sea level when the temperature is 15 degrees Celsius? Why do meteorologists use radiosondes? How does temperature affect density altitude? And how does density altitude affect aircraft performance? All right, so so stay tuned. So please subscribe, like the video, and if you have any questions, please leave them in the comment section below, and I'll be happy to answer them. But all right, well, you guys take care, and I'll see you in the next video. Thanks.